Very Swarnalatha, working as an assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on the transformation of multiple random variables. Already in the previous lecture, we have seen the transformation of a random variable for a single random. For example, if x is a random variable, by performing some operations on this random variable, you are going to get a new random variable y. Then, if fx of x is a density function of the random variable x, then the density function, the probability density function of the transformed random variable is given by fx of x into mod of dx by dy, where x equals to T inverse of y. So this is, we have seen already in the previous lecture, the transformation of a single random variable into a single random variable. In this again we have seen two types here, monotonic transformation and non-monotonic transformation. And now we are considering transformation of multiple random variables. It means you have to consider multiple random variables. Let us say we are considering n number of random variables. We are considering n number of random variables. So these n number of random variables are transformed into n number of new random variables by performing operations on this n number of random variables x1, x2 and so on xn. Then what is y1 is equals to t1 of x1, x2 and so on xn, and what is y2 equals to t2 of x1, x2 and so on xn and so on. Yn is equals to tn of x1, x2 and so on xn. It means you are taking n number of random variables and then you are transforming into n number of new random variables by performing operations. Here what is t indicates? T nothing but here transformation. It is also called as the type of operation you are performing and the random variable so that to get a new random variable. So you can perform any operations like addition, square, multiplication. So you can perform any operations to get a new random variable. Why? This is for single random variable. The same case you are considering for multiple random variables. So for the multiple transformation of random variables, you have to consider n number of random variables, and this n number of random variables has to be transformed into n number of new random variables by performing the operations on this n number of operations like t1, t2 and so on tn. And you can write this in the matrix form. So you are writing this n number of equations into matrix form. Then you can write on this as what? Y is equals to, here this is a matrix Y, which consists of how many rows? 1, 2, 3 and so on, n rows, and how many columns? Only 1 columns. Therefore, the size of this matrix n cross 1 is equals to t into x. So what is t here indicates? The transformation. So the transformation is of n by n, and here the size of the x matrix nothing but n cross 1. And what is t here? So what is the performance here? The operation performed on this n number of random variables are what? t1, t2 and so on tn. So let us consider a linear transformation has been applied on this n number of random variables. Then what is y1 equals to a11 x1 plus a12 x2 plus and so on a1n xn. And what is y2 is equals to a12 x1 plus, so this is the second row is nothing but a21 x1 plus a22 x2 plus and so on a2n xn. And similarly the nth random variable, the transformed random variable yn is equals to what? an1 x1 plus an2 x2 plus and so on ann xn. Therefore, what is y is equals to t into x. What is the size of the matrix n? Here y is nothing but n cross 1, n number of rows and 1 column. And the size of the transformation matrix, how much it is? It consists of n number of rows and n number of columns. The size of the X matrix nothing but n cross 1. Therefore, what is our transformation matrix here? T is equals to A11, A12 and so on A1n. The second row here A21, A22 and so on A2n. Therefore, here A21, A22 and so on A2n and so on here AN1, AN2 and so on AN. The type of transformation is a linear transformation. RS is also called as nothing but here dou x1 by dou y1, dou x1 by dou y2 and so on dou x1 by dou yn and so on dou xn by dou y1, dou xn by dou y2 and so on dou xn by dou yn. What does it mean here? So here, how do you get A11? You have to partially differentiate both with respect to x1. Then what can happen here? Dou y1 by dou x1 is equals to what? A11. And the differentiation of x with respect to x is nothing but x1. Remaining, when you differentiate with respect to x1, then all these are constants. Therefore, what is A11 equals to dou y1 by dou x1. And similarly, what is A12 is nothing but dou y2 by dou x2. And so on, what is ANN is nothing but dou y1 by dou yn by dou xn. So this is nothing but the coefficients A11, A12 and so on A1n. So in the transformation of n, these random variables has been the density function of these transformed random variables has been given by dou. So the nothing but the density function of x1 and so on xn of x1 is equals to t1 inverse and what is x2 equals to t2 inverse and so on xn is equals to tn inverse into mod of j. What is j here? J is called as what? Jacobian matrix. What is j is called as what? Jacobian matrix. And here mod is nothing but what? Determinant of the matrix. So we'll explain this by taking one example. So let x1 and x2 be jointly continuous random variables with PDF is nothing but probability density function fx1 x2 of x1 comma x2. And let y1 is equals to ax1 plus bx2 and y2 is equals to cx1 plus dx2 are new random variables where a, b, c and d are real constants. Find the joint probability density function of y1 and y2 in terms of fx1, x2. So what does it mean? They have given two random variables x1 and x2. So these are what? Two random variables. And then what they are given that? The joint density function of these two random variables is given by what? F x1, x2 of x1 comma x2. What is this? Nothing but what? It is nothing but the joint probability density function of the random variables x1 and x2. After that, what they have given? These two new random variables, the defined two random variables are transformed into new random variables y1, y2. Therefore, what is y1 is equals to nothing but ax1 plus bx2. Nothing but what? Transformation of x1 comma x2. It means you are performing the operations on x1, x2. How you are performing? You are multiplying the random variable x1 by a and the random variable x2 by b and then you are adding these two so that you are getting a new random variable y1. And similarly, what is y2 is equals to here cx1 plus dx2. Nothing but by performing the operations on these random variables x1 and x2, you are getting a new random variable y2. So how we are getting a new random variable y2? By multiplying the random variable x1 with c and x2 with d and then adding those two so that you are getting a new random variable y2. So these are the new random variables where a, b, c, d are the constants. So now what is the question they have given? Find the joint PDF of y1 and y2 in terms of x1 and x2. So they have given the joint density function of the random variables x1 and x2. Now we have to find out the joint density function of the transformed random variables y1 and y2. So now let us see the solution. So what is a transform? The density function of the transform random variables f for y1, y2 and so on. yn is equals to what? fx1, xn and so on. x1 equals to t1 inverse and x2 equals to t2 inverse and so on. xn equals to tn inverse. So this is nothing but what here? Jacobian matrix of the size of what? n cross n. The size of this matrix nothing but what? n cross n. So you have to find out the determinant of this matrix. Therefore, here what is y1 equals to ax1 plus bx2. What is y2 equals to cx1 plus dx2. Let us say that y1 is a function of g of x1 comma x2 and y2 is a function of h of x1 comma x2, where g comma h are the functions of the random variables x1 and x2. Therefore, what is the Jacobian matrix A? How many random variables here? 2 random variables. They are transformed 2 random variables. Therefore, what is the size of this matrix? 2 cross 2. So, nothing but 2 rows and 2 columns. So, the first one here, dou g by dou x1 and here dou z by dou x2 and dou h by dou x1. Here g nothing but what? G of x1 comma x2. And here h is nothing but h of x1 comma x2 is equals to what? Now, you have to find it out. So, what is dou y1 by dou x1? Here also, what is a11 equals to dou y1 by dou x1? What is a12 dou y2 by dou x2? So, here also, you have to write down dou y1 by dou x1 and here dou y2 by dou x2 and so on here. So, what is a12? Dou y1 by dou x2. So, here dou y1 by dou x2 and so on dou y1 by dou xn. Similarly, what is the nth row here? Nothing but dou y1 by dou x1 yn. Because in order to get an1, how do you get an1? Differentiate this with respect to x1 so that what is an1 is equals to dou y1 by dou x1. And remaining all these are constants and the differentiation of this constant nothing but 0. Therefore, what is the nth row here? Dou y1 by y2 and so on dou yn by dou xn. So, this is nothing but what? Which is called as what? Jacobian matrix. Nothing but the transformation matrix only. Now, we are finding out here what is g? Nothing but g of x1 comma x2 nothing but here dou y1 by dou x1 and here dou y1 by dou x2 and what is here nothing but a11 only. So, dou y2 by dou x1 and here dou y2 by dou x2. Nothing but what here? a11, a12, a21, a22. Therefore, what is here? A, B, C, D. And what is the determinant of this matrix? AD minus BC. Therefore, what is mod J is nothing but determinant of the matrix is equals to AD minus BC. Now, what is y1 equals to x1 plus bx2 and what is y2 equals to cx1 plus dx2. Now, we write down x1 in terms of what? y1 and y2. And similarly, write down x2 in terms of what? y1 and y2. Therefore, what is x1? We are having two equations. The two equations here, y1 is equals to ax1 plus bx2. What is y2 equals to cx1 plus dx2. Now you are having two equations and you have to find out two unknowns x1 and x2 in terms of y1 and y2. So how do you find it out? So first divide this equation with here a. Then y1 by a is equals to what? x1 plus b by a into x2. And divide the second equation by c. Then what can happen here? y2 by c is equals to x1 plus d by c into x2. Then subtract on both sides. Then what can happen here? y1 by a minus y2 by c is equals to b by a minus d by c into here x2. So from this what can happen if you take LCM? So c y1 minus a y2 by ac is equals to bc minus da by ac into here x2. So AC is get cancelled. Then what is x2 is equals to c y1 minus AY2 by BC minus AD. Or else if you multiply with minus, then what can happen here? Minus C1 plus AY2 by AD minus BC. So this is nothing but what? X2 in terms of what? Y1, Y2. And similarly, you can calculate X1 in terms of Y1 and Y2. For that, what can you obtain? So take equation 1, then divide equation 1 with B. Then what can happen here? Y1 by B is equals to A by B into X1 plus here B. And divide the equation 2 with respect to what? D. Then what can obtain here? Y2 by D is equals to C by D into X1 plus here D by D into X, nothing but here D. Then subtract on both sides. Then what can happen here? Y1 by B minus Y2 by D is equals to A by B minus C by D into X1. So from this, what is X1 is equals to dy1 minus by2 by AD minus BC. This is nothing but what? X1 in terms of, so what is X1? T1 inverse of y1 comma y2. And what is X2 is nothing but T2 inverse of y1 comma y2. So by performing the inverse operation y1 y2, you are getting a new random. You are getting the original random variables X1 as well as X2. And therefore, the density function here we are written f y1, y2 and so on, y1 to n is equals to what? F x1, x2 and so on xn, where x1 equals t1 inverse, x2 equals t2 inverse and so on. Xn equals Tn inverse into mod J, where J is a Jacobian matrix and mod is nothing but determinant of that matrix. So this is for n random variables. Now for two random variables, what is the equation you are going to obtain? You are going to obtain Fy1 comma y2 of y1 comma y2 is equals to what? Fx1 of, it's nothing but what? Fx1 comma x2 of x1 equals to t1 inverse and x2 is equals to t2 inverse into mod of j. Therefore, fx1 comma x2 of what is x1? Nothing but dy1 minus dy2 by ad minus bc, and what is x2 is nothing but ay2 minus c1 by ad minus bc into what? Determinant of the matrix. What is the determinant of the matrix here? ad minus bc. So into 1 by mod j. Nothing but what? 1 by mod j. So here, so 1 by ad minus bc, nothing but here the determinant of the matrix, nothing but 1 by ad minus bc. So like that, you can transform n number of random variables into new random variables so that you can find out the density function of the transformed random variables. So we'll go for the next question. So they have given if x and y are two independent random variables, the density function fx of x is equals to e power minus x into u of x and fy of y equals to 2 into e power minus y into u of y. So find the density function of that equals to x plus y. So they have given the two random variables x and y are which are statistically independent, and they have given the density function of the two random variables x and y. After that, they have given that they are independent. If they are independent, then what is joint density function? Fxy of x comma y is equals to what? Fx of x into fy of y. Then what is the joint density function of the two statistically independent random variables? Fxy of x comma y is equals to what? E power minus x u of x into 2 into e power minus y u of y. Then what can you obtain here? Fxy of x comma y is equals to what? E power minus x u of x into 2 into e power minus y u of y. That equals to what? 2 into e power, if you take minus common, you get x plus y into u of x into u of y. So this is what? The joint density function of the random variables x and y. So what you have to calculate here? The density function of the sum of these two random variables z equals to x plus y. Then what is z here? Nothing but the sum of the two random variables x and y. So how do you get what you are doing here? What is z equals to? Transformation of x1 comma x2. So what type of transformation are applying here? You are just adding these two random variables, not x1 x2 here. Transformation of x comma y. So by performing the operation of x and y, you are getting a new random variable z. In the previous case, you are transformed two random variables into two new random variables. Here, we are transforming two random variables into only one new random variable, z equals to x plus y. So let us consider w is equals to y. We are considering one more equation, what is w equals to y and what is z equals to here x plus y. Then from this, what is y equals to w and what is x equals to z minus y. So what is y is nothing but here w. So what is x equals to here z minus w and what is y equals to w. Then what is Jacobian transformation here? From this here nothing but here 1 0. What is Jacobian here? Dou z by dou x, dou z by dou y. So what is z equals to here? X plus y. And then what is w is equals to here? W is equals to y. Therefore what is here? Coefficient here 1, here coefficient nothing but 1 1. And here the x coefficient is 0, therefore 0, and what is y coefficient here? 1. So 1 1 0 1. Now what is nothing but here? 1. And what is joint density function of the transfer random variable? Nothing but f z w of z comma w is equals to what? Fxy of x comma y into the determinant of the Jacobian matrix. Therefore fxy of x comma y by mod of z comma x comma y. Then what is fxy of x? So what is x in terms of y? Nothing but here z minus y. What is y? Nothing but here w. Therefore what is x here? Z minus w. And what is y is nothing but w here. Therefore what is y here? W. Therefore fxy of z minus w comma w. Then what is fxy of x comma y here? 2 into e power minus of x plus y into u of x into u of y. Now in place of x and y, what do you have here? Z minus w and w. Therefore what is f of z comma w equals to 2 into e power minus of z minus w. Then we have to find out the density function of only the transformed random variable z only, not zw of z comma w of z comma w. Then how do you find out? So you know the density function of the joint density function of the random variables z and w. But what do you want? Nothing but what? The joint PDF. So you want only the density function of the random variable z w. Nothing but what? How do you find it out? By calculating the marginal density function. Therefore, how do you find out the marginal density function of the random variable z? If you want the marginal density function of z, then you have to differentiate the joint density function with respect to what? W over the interval minus infinity comma infinity. Therefore, what is f z of z equals to integration minus infinity f z of w of w into dw. Now you have to find out the limits of z. So what are the limits of w? Nothing but the limits of w is equals from where to where. So here x is greater than equals 0 and y is greater than equals 0. What is u of x? It is 1 when x is greater than equals 0, and what is u of y value? It is 1 when y is greater than equals to 0 here. Therefore, so in place of x, what do you have here? Z minus w. What is x equals to here? Previously, for x is greater than equals 0, u of x equals to 1. For y is greater than equals 0, u of y equals to 1. So in place of x, what do you have here? Z minus w. So z minus w is greater than equals 0. And similarly, one place of y, what do you have here? W. Therefore, w is greater than equals to 0. Now, from this, what can I write down here? Z minus w is greater than equals 0. Therefore, what is z is greater than equals to w. What is the w value should be greater than equals 0 and z should be what? From this less than equals to 0. Z. Therefore, what is the limit of w here? From 0 to z. Therefore, the limit of z nothing but 0 to z. F z w of z comma w dw. What is in this range? What is the density function here? Here, what is the density function? Integration minus infinity. What is the density function here? F z w of w nothing but 2 power minus z minus w. 2 power 2 into e power minus 2 into e power minus of z plus w into u of z into u of w into dw. Therefore, here, what is the density function? The range of w nothing but only 0 to z. In this range, what is the density function here? 2 into e power minus of z minus w. So, if you solve this, then what is the density function of the transformed random variable? f z of z is equals to what? 2 into e power minus z minus e power minus 2z for what values of z? When z is greater than or equals to 0. Therefore, in this lecture, we have discussed about the transformation of multiple random variables into a single random variable. Similarly, the transformation of multiple random variables into n number of new random variables. And then we have calculated the density function of the transformed random variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.